So for number 1, we are doing our chain rule, and we definitely do not want to multiply all of this out. That's what raised to the 4th power would imply for us to do. So with our chain rule, again, we are going to do the derivative of the outside times the derivative of the inside. And the derivative of 3x minus 2 is just 3. And in your final answer, you certainly can multiply those two together. So you're going to have 12 times 3x minus 2. Number 2, again, same process. We need to do the derivative of the outside. And since that 5 is already there, we're just going to multiply those two together. So we're going to have 15 times 2 minus x squared, all squared, times the derivative of the inside, which is negative 2x. And again, you would probably see as an answer choice those two multiplied together. So that would give us negative 30x times 2 minus x squared, all squared. Okay, number 3, again, same process. Doing the chain rule, it really does help clear up a lot of this other extra algebra. We're going to have 2/3 times 6 plus 3x, and then that's going to be raised to the negative 1/3, and then times the derivative of the inside. So your final answer, again, these three should cancel, so you have 2 times 6 plus 3x, all raised to the negative 1/3. Moving on. Number 4, we definitely have to do some rewriting. So first, I'm going to rewrite this to be x plus 3, all raised to the 1/2. Now we're ready for our derivative. F prime, again, derivative of the outside times the derivative of the inside. And for this one, there's not much clearing up here. F prime at x equals 1/2 times x plus 3, all raised to the negative 1/2. Okay, moving on. Again, with these, we do need to rewrite them. And so here we're going to have g at x equals x squared minus 9, all raised to the 1/3 power. So g prime at x is going to be 1/3 times x squared minus 9, all raised to the negative 2/3 times the derivative of the inside. And again, putting this together to match an answer choice that you would have, these would be put together. So we're going to have 2x over 3 times x squared minus 9 to the negative 2/3. Okay, for this one, we would move all of this up to the top. So we're going to have y equals 2 times, and we have x squared minus 3x minus 4, all raised to the negative 2. So y prime is going to be, and you would multiply these together, so negative 4 times x squared minus 3x minus 4, all raised to the negative 3, and then times the derivative of the inside. So we're going to have 2x minus 3. And I would leave that just like that. Okay, for 7, let's do some rewriting. F of x equals, we know 3 squared. That's just going to be 9. And then in the denominator, we're going to just say 3 minus x, all squared. Now we can go ahead and flip this over. So again, still rewriting. So f of x equals 9 times 3 minus x to the negative 2. Now we're ready for our derivative. F prime at x equals, that's going to be negative 18 times 3 minus x to the negative 3 times the derivative of the inside. Okay, for this one, you've got a couple of options here. We can flip this up to the top and do our product rule. We most certainly can do that. or we can leave it in the denominator and do the quotient rule. And it looks like almost that the quotient rule might be the best way to go here because it's still going to be messy no matter which way. So here, g prime at x, we have the bottom times the derivative of the top, and the derivative of secant x is going to be secant x tangent x. So again, bottom derivative of the top minus top times the derivative of the bottom, and we're going to have to do our chain rule there. That's going to be 3 times x plus 1 all raised to the second times the derivative of the inside. So we have all of that, and then every bit of this is over the bottom squared. And again, I would not do anything else to this because you would end up substituting in some kind of trig value. Okay, so number 9, we are going to start out by rewriting. So we have y equals 2x squared minus 5x plus 3. That's all raised to the 1/3. So we have y prime. It's going to be 1/3 times 2x squared minus 5x plus 3, all raised to the negative 2/3, and then times the derivative of the inside. So we're going to have 4x minus 5. Okay, for our next problem, we need to do our product rule. H prime at x equals, we have the first, and then times the derivative of the second, so we need to do our chain rule here. Derivative of the outside times the derivative of the inside, plus second times the derivative of the first. All right, moving right along. Here we're going to have to rewrite and do our product rule. So I have x times 1 minus x squared, all raised to the 1/2 power. So y prime first times the derivative of the second. Oh, that needs to be a 1. Sorry, folks. 1 minus x squared to the negative 1/2. First derivative of the second times the derivative of the inside. So negative 2x. And then plus the second times the derivative of the first. All right. And here that 1/2, you have a couple of options on 12 with the 1/2. You really can just leave it sitting out there and focus on all of this on the inside. And that might be the best route for this. And then do your product rule. And of course that has to be to the 1/2 power. Remember that is 4 minus x squared to the 1/2. And so with our product rule, we have the first times the derivative of the second, and the derivative of the second, we're going to have our chain rule, 1/2 times 4 minus x squared to the negative 1/2 times the derivative of the inside. Okay, oh, I don't need to close that bracket there. Or yeah, I do, sorry. And then, let's see, first derivative of the second plus second times the derivative of the first, which is 2x. And there you go. Looks like we're going to have to rewrite and use our quotient rule here. So the denominator, do you remember, that changes to x squared plus 1, all raised to the 1/2 power. So f prime at x, we have the bottom times the derivative of the top minus the top times the derivative of the bottom, and we're going to need our chain rule here. Okay, and then that's all over the bottom squared. So we have x squared plus 1 if you square that square root. All right, and again, don't try to do much simplifying, just leave it like it is. Over here on this one, let's rewrite this to be t minus 3 all squared over t squared plus 2. That's one way we could do it, all squared, Or we could do the chain rule like it is. Let's try the chain rule like it is just to see. Again, that's going to be the derivative of the outside to the first, and then times the derivative of the inside, which is going to be our quotient rule. So we have the bottom times the derivative of the top minus the top times derivative of the bottom, and all of that's all over the bottom squared. All right. Okay, now with our trig functions, this is where we really use that chain rule quite a bit, and that's because all of this is our angle. So here when we do our derivative, y prime, the derivative of the outside would be doing the derivative of your trig function. So the derivative of sine of an angle is cosine of that same angle. But then it's going to be times, and then here comes the inside part, the derivative of e to the 2x, which is going to be stuff prime, so the derivative of 2x is 2, times e to the stuff. And you're finished. Okay, so again, 16, a lot of the same. The derivative of the outside is when you're doing the derivative of tangent, which is going to be secant squared of whatever angle I have, which is natural log of x, times the derivative of the inside. Now, all of this is one quantity, times the derivative of the inside. So the derivative of natural log of x, well, that's going to be stuff prime over stuff, or 1 over x. So again, the same thing here, the chain rule we are going to use here, f prime at x equals, well, the derivative of the outside is going to be negative cosecant theta prime, or theta squared, sorry, times cotangent theta squared, and then it's going to be times the derivative of our angle, or the inside, so that's going to be 2 theta. Number 18. I would rewrite that to remind ourselves that that is cosine of x to the 1/2. So y prime, derivative of the outside is going to give us negative sine x to the 1/2 power, times the derivative of the inside, which is going to be the angle, which is going to be 1/2 x to the negative 1/2. Okay, number 19. Now 19, we have to be careful because here we have an exponent on that trig function. So that's going to change things a bit. And I'm going to rewrite this so that I have 4 is just that coefficient. So don't do anything with it. Just let it sit there. Sine of pi theta all squared. Right? So now we're ready for g prime at theta equals, well, the derivative of the outside here, we're going to multiply that down. So we have 8 times sine pi theta all to the first. And there's really like 3 different steps inside this that we're going to do. We take care of that outside. Now, when we do the derivative of the inside, well, we have another chain rule. So we have to do the derivative of the outside. The derivative of sine is cosine pi theta, and then times the derivative of the inside. So the derivative of pi theta is just pi. Okay, let's try number 20. So again, we have our chain rule. Y prime equals, we're going to do the derivative of the outside, so the derivative of sine of all of this angle is going to be cosine of all of this angle. And then we're going to have times the derivative of the inside. Well, the derivative of the inside part, well, we're going to have another outside part. So that's going to be negative sine of 3x squared. And then we've got to do the derivative of the inside, so that's going to give me 6x. All right, that one was messy as well. Okay, now we're going to start writing our equation of tangent lines, and that's never ever going to go away. And we do need to remember that formula, and y'all are very good with remembering it. We do need to rewrite this, though, so that we have y equals, and we're going to make our exponent to the 1/2 power. And keep in mind, they've already given us an x and a y, so we don't have to go find the y. So y prime equals, we're going to have 1/2. So again, we're doing the derivative of the outside, and then times the derivative of the inside. And this is a great illustration of why we say never ever simplify anything, because now we're going to go and we need to find y prime when x equals 2. So we're going to have 1/2 times, well, 2 squared, we're going to have 4 plus 6 plus 6 raised to the negative 1/2 times 4 plus 3, which is 7. So for this, let's see what value we get here. We have 6 plus 6, that's going to give me 12, and 4 is 16. So we have 1/2 times 16 to the negative 1/2. Well, that's 1 over the square root of 16, so 1/4. And then times 7. So it looks like we have 7 over 8 is our slope. So we're now ready to write our equation. So we have y minus 4, that was given to us, equals our slope, which is what we find from our derivative, times y minus, x minus 2. Okay, so again, same process over here with 22. Let's go ahead and find our derivative. So we have 2 times x squared plus x minus 2 times the derivative of the inside, 2x plus 1. And then we need to find our derivative value when x equals negative 1. And so we have 2 times, that's going to be 1 minus 1 minus 2 times negative 2 plus 1, so negative 1. So let's see if we can figure out what our slope should be. We're going to have, let's see, those cancel, so negative 4 times negative 1, so positive 4. So now we're ready to write our equation. Y minus 4 equals 4 times x minus a negative 1. Okay, same process even with our trig functions, nothing changes. So here, again, we already have our x and our y value. We do need to find our derivative, so y prime equals derivative of the outside times the derivative of the inside. And now we need to find y prime when x equals pi over 3. So here we're going to have cosine of 2 times pi over 3, and then times 2. And so we need to know cosine of, here we're going to have 2 pi over 3. So cosine of 2 pi over 3 is going to give us 1/2, negative 1/2. Took me a minute to think about that one. So I have negative 1/2. All of this is negative 1/2 times 2. So that's going to give me negative 1. So the slope here is negative 1. The equation y minus negative 1 equals our slope times x minus our x1, which was this time pi over 3. All right. Continuing on, number 24, more of the same. So again, we start out with our y prime. Doesn't look like anything needs to be rewritten. We do the derivative of the outside times the derivative of the inside. And now, again, this is a great place where we don't worry about simplifying right now. Don't worry about that. We are going to find y prime at 1. So that's going to be 1/3 times, well, that's going to give me 8 to the negative 2/3 times negative 2. So that's going to give me 1/3 times, well, we have 1 over because of the negative. The bottom is our root, so the cube root of 8 is 2, and 2 squared is 4, so this is 1/4, and then times negative 2. So it looks like we're going to get a slope, y prime, at 1 is negative 1 over 6. Now the equation is going to be y minus 2 equals negative 1/6 times x minus 1. Okay, more finding the derivative. Now I would, again, that 2, I would rewrite this to help myself remember that I'm going to have chain rule for days on this. So we're going to have h prime at x equals, and this is their product rule, so we have our first times the derivative of the second, which we have to do the derivative of the outside, so that's 2 sine x raised to the first, times the derivative of the inside, so the derivative of sine is cosine of x, times the derivative of x, which is 1. So first, derivative of the second, plus the second, which you can write either way you want to. So you can write it sine x all squared if you want. So that second times the derivative of the first, and derivative of e to the x is still just e to the x. Okay, for this one, we do need to do a little bit of rewriting to simplify this a bit. Here that 3 can move down to the front, and that's going to make things a bit easier for us because we would have 3, and we can think of that as times natural log of x times cosine of x. And that does make our derivative a bit easier. So we're going to have f prime at x equals, we have 3 times, and now we're going to do our product rule. So we have the first times the derivative of the second, which is going to be negative sine x, times the derivative of x, which is 1, plus the second times the derivative of the first. And we're going to leave it just like that. All right, so moving on. So notice that all of this stuff here in parentheses, that's all of the stuff that we talk about when we say stuff prime over stuff with our natural log. So g prime at x is going to be stuff prime, so the derivative of all that, 3x squared minus 2, back over the stuff. All right, and that's it for that one. So knowing that little trick really does help. And again, notice how all of this is in parentheses, so all of that's your angle. And we still do y prime equals derivative of the outside, which is going to be cosine of x squared plus 3x. So there's the derivative of the outside times the derivative of the inside, which is going to be 2x plus 3. Okay, so notice inside the parentheses, this is the angle for cosine. And we do have 2 separate functions here, so we are going to do our product rule. Y prime equals first times the derivative of the second, so we're going to do the derivative of the outside, which is going to give me negative sine of the angle, and then times the derivative of the inside, which is going to give me 1 over x. So there's first derivative of the second plus the second, which is going to be that long cosine mess, times the derivative of the first, which is 1. Okay, so number 30, we do need to rewrite this so that we have f of x equals sine x cosine x all raised to the 1/2 power. So f prime at x is going to be derivative of the outside, so 1/2 times sine x cosine x to the negative 1/2, and then times the derivative of the inside. So the derivative of the inside is going to be the product rule. So I'm going to do a bracket here. We're going to have the first times the derivative of the second plus the second times, and I'm out of room, the derivative of the first. All right, there you go. Moving on. So let's see, 31. We have some rewriting to do here. This looks absolutely terrible, but we can simplify this up. Don't let this overwhelm you. The first one, I would flip this up to make it a negative exponent here. So g of x is going to be pi is the coefficient of x to the negative 3. And then minus, and we can rewrite cosine and tangent. Well, we have cosine of x, and I'm going to put that over 1 because I know tangent is sine x over cosine x, and those cosines will cancel. So the rewriting here, g of x equals, that's going to give me pi times x to the negative 3 minus just sine x. And notice taking that little bit of time and rewriting it really has made this derivative become a lot easier. So we're going to have g prime at x equals negative 3 pi x to the negative 4. Again, pi is just a coefficient sitting there, so when I bring down that negative 3, it's times. And then minus the derivative of sine of x is cosine of x times the derivative of x, which is just 1. All right, so let's look at 32. We have h prime at x equals. No, really not necessary in rewriting too much here, just other than that can be x to the negative 1. So we do the derivative of the outside, so we're going to have negative sine of x to the negative 1 times the derivative of the inside, so derivative of x to the negative 1 is going to be negative x to the negative 2. Okay, moving on. More of the same. So here we have to do our derivative. So the derivative of tangent, derivative of the outside part here is going to be secant squared. So y prime equals secant squared of the given angle, theta squared minus 3 theta. And then times, now theta is like an x here, so times the derivative of the inside. So we're going to have 2 theta minus 3. All right, moving on, and that's it for that one. More of the same here. So 34, f prime at x equals, and we're going to have to do the derivative of the outside first. Okay, and that's going to be to the positive 1/2 when I subtract 1, times the derivative of the inside, which is going to be 2x plus, and that 3 here is just your coefficient, so it's going to move right over, and the derivative of e to the x is e to the x. All right, so now we're to more of a general notation, which is usually what you see for a lot of these. And, well, it can be a mixture. It's not just the only thing you see. It's a good mixture of all of it. So notice that we need to find the derivative of f of g of x at x equals 2. Well, the derivative of f of g of x is just like what we've been doing. You first do the derivative of the outside times the derivative of the inside, and then you would still take the derivative of x, which is just 1. So notice here's what we have with our derivative. So now we need to find that derivative value at 2. So I need f prime of g at 2 times g prime at 2 and times 1, so we don't have to write that. So g at 2 is going to be 3. So now I need f prime at 3 times, and we can go ahead and find g prime at 2 is negative 2. And so f prime at 3 looks like it's going to be 2 pi. So 2 pi times negative 2, that's going to be negative 4 pi. All right, so let's look at our next problem. More the same as your general functions, which should be okay. We do need to rewrite this though. That is f of x times g of x, all raised to the 1/2. So our derivative here, we do the derivative of the outside. We do need that chain rule here to the negative 1/2. And then times the derivative of the inside, and I'm doing that bracket because I have the product rule here. So I'm going to have the first times the derivative of the second plus the second times the derivative of the first. All right, and so we're ready now to sub in 2. Now we have quite a bit of stuff here that we're going to have to plug into, so be careful with this. We're going to have 1/2 times, and if we do f at 2, let's go see what f at 2 is going to be. 6. So we're going to have 1/2 times 6 times 3, and all of that's to the negative 1/2 times, well, f at 2 again. Well, f at 2 is 6, so we're going to have 6 times g prime at 2, which is negative 2, plus g at 2, so 3 times f prime at 2, which is 1. Or I think there's a correction here. Let me look. Yeah, f prime at 2 is 1/2. My version was different from y'all, so 1/2. Right, and let's see. So now we're ready to try to put some of this together. However, if this was free response, don't do anything else to it. And I'm kind of not a real big fan of doing anything else to it. Anyway, so if we wanted to, if we just had to, could not stop ourselves from simplifying here, we're going to have 1/2 times, and let's see, we're going to have 1 over the square root of 18 times negative 12 minus 3/2. And I really would not do much more to it than that. So let's just leave it like it is. All right, and now for 37, we have to find the value of h prime at 3. So we need to find the value of h prime at x first. So we're going to have to do our chain rule. We're going to do 2/3 times 4 f at x plus g at x. And all that's raised to the negative 1/3, and then times the derivative of the inside. So we're going to have 4 times f prime at x plus g prime at x. Now we need to see, well, what is h prime at 3 equal to? And now we do our substitution. So we have 2/3 times, this is going to be 4 times, and we need f at 3. F at 3 is going to be 2, plus g at 3 is going to be negative 4, and all of that's raised to the negative 1/3 times 4 times f prime, so that's going to be 4 times 1/2. To remember that's different on y'all's, and times g prime, so that's going to be g prime at 3. G prime at 3 is going to be 5. Oh, and this isn't half. I wish you would fix these. All right, so instead of that, I have to go back and look. I think y'all's is, I'm going to say 2 pi there, f prime at 3. It's 2 pi on my version. And again, let's just leave it like that. Don't do any differences to it. Now, number 38, this again is testing for concept. Notice it's not just finding the derivative here. so much as it's seeing, do you understand this notation, which this is an ordered pair for your derivative. And your derivative, well, your original function looks like this. And k is some positive value, and it is a constant. So what we'll need to do with this is some rewriting at first, because we know an exponent sitting on the outside with that logarithm moves down to the front. So we have p at x equals, I'm going to move that k down here to the front, so I have k times natural log of 4x minus 5. And so when we do our p prime at x, that k is just going to sit there. It's some coefficient times, well, we're going to do our stuff prime, so that's going to be 4 all over stuff. Now, and then if we simplify this up, remember we can put k over 1 and multiply across the top and bottom, so we have 4k over 4x minus 5. Now, this is where the other piece that we're given we need to use. We are told that p prime at 2 is 8. So that means when x is 2, then our derivative value is 8, or my y value here is 8, y prime value, sorry. So let's come over here and look. Well, p prime at x, we're going to change that to be 8 equals 4k, because again, k is the constant that we're looking for, over, and I'm going to plug in a 2 for x, so that's going to give me 8 minus 5. So here we have 8 equals 4k over 3, and so to solve for k, remember we would multiply that 3 over, so we have 24 equals 4k, so it looks like k is going to have to be 6.